Good morning, Overlc Middle School students. This is Mr. Woolley, and we are going to go ahead and continue on our lessons. And we're on lesson 16 today, relating scale drawings to ratios and rates. And you want to guess a couple images here. First one we have is a subway map. And this is actually called a reduction because it's a smaller version of what an original subway plan would look like. Here I have a picture of a fingerprint. This is actually an enlargement of a fingerprint because no one would have a fingerprint quite this large. So it's referred to as an enlargement. Now what we're going to have then, using those terms, reduction when something is shrinking down, and enlargement when something has grown bigger, is we're going to take a look at a pair of pictures. So our example 1, for the following problems, A is the actual picture and B is the drawing, is a drawing, an enlargement, or a reduction of the actual picture. As you move from picture A to picture B, it has gotten larger, so that was what I would refer to as an enlargement. As I move from the number line here in number 2 in A to the number line in B, it has shrunken down and got smaller. This is a reduction. All right? So if you start small and go bigger, then that's an enlargement. If you start big and go small, that's a reduction. All right? Next up, what they want to do, they have two pictures here. They want to know what are the corresponding points on the scale drawings of the maps. So you just got to kind of play around. This would have to, they're not positioned exactly the same. So you have to kind of maybe in your mind spin and pivot it around. But point A would match up with point R. Point V would match up with point W. Point H would match up with point P. And point Y would match up with point N. So just a couple things there that you could kind of look at. All right. And now here's kind of like some of our main concepts for the day then. It says that, for example 3, Celeste drew an outline of a building for a diagram she was making, and then drew a second one mimicking her original drawing. State the coordinates, vertices, and fill in the table. All right, our original drawing, it's pinpointed there, and I kind of redrew just to kind of highlight it a little bit more. It's 18 for the height, and the length of it, or width, whatever you want to refer to it as, is 6. And our second one is 9 and 3. So as we go from a larger to a smaller, we do know that that second drawing is a reduction. So we do know that because it's smaller. Now, we want to see, as we look at these, as we go from a constant proportionality, it's a y value divided by an x value. Now my original information here, I'm going to refer to as an x value, and my newest information is going to be a y value. All right? So if I took the heights and compared them, if I took my new height divided by my original height, 9 divided by 18 is 0.5, or 1/2. And if I do that same thing for the length of my second drawing, if I took my 3 divided by my 6, remember y values divided by x values, once again, I get 0.5, or 1/2. So that constant proportionality is 0.5. It's proportional because both the height and length were half of the original. We know this is a proportional relationship. We know they're scale drawings of each other because you had that same constant proportionality between the height and the length. They each grew to half the size. All right, let's take a look at triangles as well. We have a situation that they talk about there, and they have the triangles already drawn in for us. The first triangle has a height of 5 and a width of 3. And then that second triangle has a height of 15 and a width of 10. So same kind of scenario. I write down the original height and the original width. And then I write down the second or newest image, height and width. And then remember, I'm going to take my y values divided by the x values. And as you can see, from here to here, I did get larger. So now this is an enlargement I'm dealing with. So I took 15 divided by 5, I get 3. If I took 10 divided by 3, if you punch it in your calculator, because it's not a regular math fact, it's 3.333. So I have 3 times bigger for the height and 3.3 repeating times bigger for the width. This is not a constant proportionality here that they got different numbers. So it does grow at a different rate. So is this a scale drawing? No, the measurements must grow or shrink at the same rate. All right? So if you keep taking your y values, your newest information, like the new picture, divided by the same measurement in the old picture, you can find what that constant proportionality is. All right, well, thanks for watching, and you should have a little assignment that you'll see in Schoology following this. Thank you.